Alrighty, in lesson 7, we talked about completing the square when a was 1. You also had the opportunity to look at an additional note video of how to complete the square when you had a leading coefficient of something other than 1. In lesson 8 today, we're still going to be completing the square, but we are going to focus on writing quadratic functions in vertex form. Okay, we're going to use completing the square to write it in vertex form. All right, if you want an additional challenge, you can also solve the real life problem. This is an example where we complete the square to get a quadratic function in vertex form when the leading coefficient a is not 1. So it says writing quadratic functions in vertex form. Recall that the vertex form of a quadratic function is a x minus h quantity squared plus k, where h comma k is the vertex of the graph of the function, right? We like our functions to be written in vertex form because then the left, right, up, down shifts make it easy to identify the vertex. You can write a quadratic function in vertex form by completing the square. The first thing we're going to do is move the constant over, okay, same beginning as what we did when we completed the square. We'll factor out a if there is one. Remember, you don't need to worry about factoring out 1, all right? So if your leading coefficient's 1, you can skip step 2. Then step 3, we're going to complete the square and balance. So we're going to complete the square on the side of the equation with the x squared and the x term. We'll need to divide the constant in front of the x term by 2 and square it. So this is our little shorthand for that, b over 2 squared. And we're going to balance the equation by adding the same value to the other side of the equation. Okay, and this is for the more advanced questions. For a when it's not 1, you need to make sure that if you factor something out of the left side that's not 1, then you multiply it back in when you add it to the right side. Okay, you must do so to keep the equation balanced. All right, so if you're interested in that real world problem today, you're going to see an example where you have to make sure that you're being really careful about what you're adding to each side to balance the equation. Okay. Step 4 is to factor and simplify. We're going to factor the side of the equation with the x squared and x term, simplify the other side. So you're going to have something where you have a quantity squared equal to another number. And then from here, we're not going to solve for x. You're going to see this note, don't solve for x if we're trying to get it in vertex form. What we're going to do is just get y by itself. So after step 4, you're going to stop and then move the constant back over. All right, so let's take a look at example 1 here.
So now what we're going to do is we're going to write quadratic functions in vertex form using completing the square. Okay, so you know how I used to give you an equation for a function that looked like this, ax squared plus bx plus c, and I'd tell you to graph it, and you'd have to use negative b over 2a, and you'd have to remember that formula. What we're going to do is I'm going to take a function that looks like this, and I'm going to write it in vertex form. Vertex form, remember, is the one where you can clearly see all of the transformations. Okay, so if you can get it into vertex form, you can easily identify what the vertex is without having to use that negative b over 2a stuff. So that's the benefit. So it says write y equals x squared minus 2x plus 18 in vertex form, then identify the vertex. You could check your work at the end, right? We know we can check it with negative b over 2a, f of negative b over 2a, using the original function. Okay, but it's just going to be easier to identify the vertex once we get it in vertex form. I'm going to follow the same steps as completing the square. Here we go. What's step 1? What do I do with the constant? What do I do with the constant? Move it over, right? This is the only thing that's a little bit different is that it's not going to be set equal to 0. It's going to be set equal to y. So that's okay. Okay, so we're going to move the constant over. So I'll have y minus 18 equals x squared minus 12x. See how I move the constant over? That's my step 1. Step 2 says factor out the leading coefficient in front of x squared. If the leading coefficient is 1, you don't have to worry about factoring a 1 out. What's the leading coefficient in front of x squared here? 1. Okay, so really I can skip step 2. All right, step 2, we're going to skip it. Okay. Now we're on step 3. Step 3 says complete the square on the side of the equation with the x squared and x term. So that would be this right-hand side. See how the right-hand side has the x squared and x term? I'm going to have y minus 18 plus box equals x squared minus 12x plus box. We want to complete the square on this side of the equation with the x squared and x term, this side. How am I going to know what goes in that box? Yep, b divided by 2 squared, right? Whatever the number is in front of x, we're going to divide it by 2 and square it. Okay, so I'm going to take negative 12, and I'm going to divide it by 2, and I'm going to square it, and that's what's going to go in the box. So what is that? Negative 6 squared, yep, good, 36, excellent. So now this side of my equal sign is heavy. Oh, plus 36. What do I have to do? Add 36 on the other side. Okay. Let me just clean this up a little bit. I lied. Let's keep going. Step 4 says factor the side of the equation with the x squared and x term. Okay, so step 4, we need to factor the side of the equation. How is x squared minus 12x plus 36 going to factor? How do I write that as a binomial squared? Very good. X minus 6 quantity squared. And on the left-hand side, I'm just going to combine some like terms. This will be y plus what? 18? Okay. All right. That's it. So we get through step 4. And then I want you to stop following your sheet. Okay? We just need vertex form. Do I need to solve for x? No, I just want vertex form. So once I get through step 4, the only thing left I have to do is move the constant back over. See how if I move the constant back over, at this point I have y equals x minus 6 squared minus 18. Oh, look at that. Where's my vertex? We have a shift right 6, down 18. 6, negative 18. That's my vertex. Hey-o. Pretty cool, huh? It's not even as hard as a fool completing the square problem because you don't have to solve for x. You get to step 4 and you stop and you just move the constant back over. Okay? Not too bad.